Let's complicate things a little bit. We're going to look at polyatomic ions. Polyatomic, poly means many, atomic is atom, and ions is anything with a plus or minus charge. Anions or cations. Again, if you don't know anything about those, go back and look at the ionic compound videos and it will explain those. The other thing is a formal charge. So what we call these when we start to build this structure, that right there, that NH4 plus, that is the formal charge. So we'll show you where that number comes from in the next couple of slides. Let's start off with ammonium. The last one was ammonia. This one is ammonium. Notice it has 4 hydrogens instead of 3, and it has an overall positive charge. But the rules are the same. So let me get out my pen. I just need to break apart the pieces and add up the valence electrons. That's what it says to do for number 1. So I've got nitrogen, and I've got hydrogen, but I've got 4 hydrogens. And if I look at hydrogen right here, it's got 1 valence electron. 4 times 1 is going to give me 4 electrons. E negative is abbreviation for electrons. And I find nitrogen, it's over here in the 1, 2, 3, 4, 5. That means it has 5 valence electrons. 5. I'm just going to move it over here to make it easy. I add these up. 5 plus 4 gives me 9 electrons. Now here's an interesting thing. This plus means that my ammonium has an overall positive charge. Now we know that electrons have a negative charge. So if one of these electrons were to go away, I would have 1 fewer electron than I did before, which means I would now have an overall positive charge. So I need to get rid of one of my electrons to account for this positive up here. Okay? And that means I only have 8 electrons to build my structure with. Again, this is really important. Right here, because of this overall positive charge, I had to get rid of an electron. We'll look at what happens if that's a negative charge in just a minute. Let me get rid of some lines. We've got 8 electrons to build our structure with, and I do exactly the same thing I did before. I'm going to put my nitrogen in the middle, and then I'm going to draw in my bonds. Now before I was drawing in all of the electrons, that gets a little tedious. So that was more for example. This is really, excuse me, how I draw it out. We got nitrogen and we got 4 hydrogens. So we know that we can only make 4 bonds with anything because we only have 4 places where we can share. So when we draw this structure out, now we need to count up, well, how many electrons did we use when we built the skeleton structure? Okay, so we just built the skeleton structure. Now we need to use up all of the other electrons. But let's see if we have any electrons left. We've used 2 in this bond, 2 in this bond, 2 in this bond, and 2 in that bond. That gives me a total of 8 electrons we've used. And if we look down here, we can only use 8 electrons. So we don't have any left. We don't have to do anything else except, do we need to add brackets if the compound has a formal charge? Does this have a formal charge? Right here it does. So yes, we do need to add our formal charge on this, or add brackets, and we do that just like this. There's my plus, same plus that I have right there. Then I don't have any resonance structures. We don't know what that is yet. I'll show you in just a bit. And then I need to check my answer. So every one of the electrons, or every one of the elements, should have 8 electrons around it, except for the hydrogen. It only needs to have 2. I go to check my hydrogens. This hydrogen has 2, this hydrogen has 2, this one has 2, and this one has 2, so all the hydrogens are happy. The nitrogen has 2, 4, 6, 8, so it's happy, and it looks like this is the correct structure. I'm going to erase this and show you the real one. Here's the cleaned up version of what we just did. Notice we have the plus up above our brackets to show that this whole thing, everything that we drew inside these brackets, is missing 1 electron. 1 electron had to go away in order for this to form. Okay, phosphate. So what happens if we have a negative ion? Well, we follow the same rules. We go down here to number 1, and number 1 says we break everything apart and we add it up. So we've got a phosphorus, we've got oxygen, and we have 4 of those. So we look up phosphorus, which means it has 5 valence electrons. Oxygen is over here next to it in the 1, 2, 3, 4, 5, 6, so it has 6 valence electrons. I'm just going to move this over to make the math easier, and we have 6 times 4, that equals 24. 5 plus 24, again these are electrons. 5 plus 24 gives me 29 electrons. So I've added everything up and I've got 29 electrons, but I got to be really, really careful, because remember, this is a polyatomic ion. So that 3 negative electrons have a negative charge, right? So if I have a 3 negative, it means that 3 electrons had to join this whole molecule when it was forming in order for it to stay together, which means I get to add 3 more electrons to build this thing. So when I add that up now, I've got 29 plus 3, that gives me 32 electrons to build this structure. I come down here and I need to build the skeleton structure. So I put my phosphorus in the middle, and I know that it's got 4 oxygens, and it's going to bond at each one of those right angles. So I've got oxygen, 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 and oxygen. And now I start placing my electrons. Now if we go back and we look at how many electrons we had 32 that we could put on here. And I've just used 2, 4, 6, 8. I like to add them around the outside edge first. So I've used 8, and I'm just going to start adding these up in a pair. Before I was showing that we were not putting them in a pair because electrons don't pair up until they have to. But just for the sake of time from here on out, I draw them in pairs, and then I'll show you we can always erase and move things around. Again, so I've used 2, 4, 6, 8. Just add them around the edge. It doesn't matter where you start. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And I've used all of them up because I only had 32 to begin with. So I move on. I've used all the electrons. I can only use as many as I have in step 1, and then I need to add brackets and the charge if the compound has a formal charge, which it does up here, 3 minus. So I need to put these brackets around the outside edge, and I need to show the overall formal charge, which was 3 minus. Then I draw resonance structures. I don't have any of those. I just need to check my answer. So the way I check my answer, all of them should have 8 around it. We don't have any hydrogens this time, so every one of them should have 8 when we're done. Let me start with the oxygen we started with. It's got 2, 3, 4, 5, 6, 7, 8. This oxygen has 2, 3, 4, 5, 6, 7, 8. This oxygen has 2, 3, 4, 5, 6, 7, 8. This one has 2, 3, 4, 5, 6, 7, 8. All the oxygens are happy. Go to the phosphorus. It has 2, 4, 6, 8. Everybody's happy. We can't be wrong. This is the structure for phosphate. When we're dealing with acids and bases, hydronium is really important. You'll see that in one of the videos that comes a little later on, learning about excuse me, about acids and bases. But we're just going to do the exact same thing. I'll go through here pretty quickly. If you need to slow it down, go ahead. I add them up. I've got hydrogen. I've got 3 of those hydrogens, and I know that hydrogen has 1 valence electron. 3 times 1 gives me 3 electrons. Got the oxygen. Oxygen is right over here, which means it has 6. So I'm going to move this 6 over here. 6, 7, 8, 9. I have 9 electrons, and this has an overall formal charge of a plus, which means one of the electrons, one of the negative particles, must have gone away. So I need to get rid of one of the negative particles because the whole thing has an overall positive charge. That means I have 8 electrons to build my hydronium with. I put my oxygen in the center, and then I start putting my hydrogens around the outside edge. I've got a hydrogen, 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 so I've used up all 3 of my hydrogens. So I've built my skeleton structure. Now I need to add electrons wherever I need to add those. I've used up 2, 4, 6. That means I have 2 more I get to use because I have 8 total. I can put those around the oxygen. I need to add brackets if I have a formal charge, which I do. So I put the brackets and I add a plus. I'm getting that from right up here at the top. Let me clear some of that up so you can see it a little more easily. And then I just count up and see if I'm correct. So check my answer. This hydrogen has 2, this has 2, this hydrogen has 2. I'm good there. The oxygen has 2, 4, 6, 8 around it. Everybody's happy. And now I can draw my Lewis structures even when I have a polyatomic ion. One more as an example. Let's draw out perchlorate according to the instructions or the rules I have down at the bottom. We got to add up how many valence electrons we get to build this thing. We've got chlorine and we've got oxygen. We've got 4 oxygens, so I'm going to put a 4 there to remind me. Come over and find my chlorine. It's in group 1, 2, 3, 4, 5, 6, 7. So it has 7 valence electrons. I find oxygen right here. It's in 1, 2, 3, 4, 5, 6. So it has 6 valence electrons. I'm going to put my 7 electrons over here just to make it easier. 6 times 4 is 24 electrons. I add those together. I get 7 plus 4. I get 31 electrons. One thing I have to remember is this is perchlorate ion, right? So it's got an overall negative charge. I can't leave that off. That overall negative charge tells me that an electron, a negatively charged electron, had to come in and join this. So I have to add an electron down here at the bottom so that I have the correct number of electrons to build this. That gives me a total of 32 electrons. Let me circle that. Go ahead and build my structure. I've got chlorine at the center. I know that because there's only 1 chlorine, and if I look up the electronegativity on the periodic table, it's going to be lower. I've got 4 oxygens. They must bond out this direction. Gives me all of my oxygens. I've got my skeleton structure down here, number 2. I'm going to put in my electrons till I use up all 32 of them. I've already used 2, 4, 6, 8. Let's just start adding them in. 9, 10, 11, 12, 13. Let me go back, sorry. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I have used up all 32 of those. I add brackets if I need to, which I do because it has an overall negative charge, if it will allow me to do so. Put my other bracket over here. And this has an overall negative charge, so I put the negative up there. I check my answer. All of them should have 8 valence electrons around. This oxygen has 8, this oxygen has 8, this oxygen has 8. Same here. And the chlorine is 2, 4, 6, 8. Everybody's happy. This is my structure for, if I clear those off, this is my structure for the perchlorate ion. So what happens when you run out of electrons and you're building your structure? Well, it is possible that you're going to need to use multiple bonds to build it.